Well, if you use the prediction routines within Mnova, sometimes you might find that certain classes of compounds give quite poor predictions. And salts are one such example. And the reason for this is that the way we often represent salts is not in their charged state, but in the neutral species. So in this particular case, we've got a hydrochloride salt of this molecule. And what would normally happen in solution is the proton from the hydrochloride would end up protonating this nitrogen. Now, if we predict this as it stands at the moment, what the software will do is it doesn't know how to protonate a nitrogen, so it will see this as being the neutral species. So I'm just going to do the prediction here, and we'll see what comes out of that. So at the top here we've got the predicted spectrum. This is our experimental spectrum underneath, and immediately we can see that some of the signals have actually quite poor prediction. So for example, the ethyl signals here, these quartets, they're predicted at 2.7 roughly, and we're seeing them at 3.2. So they're about half a ppm away from where they should be, which is not great. And likewise, this methylene here is predicted at 3.3. It's actually at 4.2. So that's almost a ppm away from where it should be. Now, obviously that's not great, but it's actually very easy to fix this and do the right thing with it. So I'm just going to get rid of that prediction. And what I'm going to do now is I'm going to modify the structure to represent what's actually in solution. And to do this, we just go to the molecule tab, we select atom charge, and I can put positive charge on here, which will effectively protonate it. And then I can put a negative charge on the hydrochloride, which effectively abstracts the proton for it. So now we've got the charged species, and this is probably a good representation of how the compound is in solution. So let's try that prediction again. So I'm going to the prediction tab, I'll do predict and compare, and let's see whether we've made any great improvements with it. Well, immediately we can see that the signals around the nitrogen have been dramatically improved. So for example, the ethyl signals are now predicted exactly where we're observing them, and likewise this methylene, which was almost a ppm out before, is being predicted exactly correctly. So just a simple change and you can end up with really good predictions. So if you come across this situation in the future, just remember the little trick of adding the charge onto the nitrogen, and then you'll end up with much better predictions. So thanks very much for watching.